Okay, so work in progress, or in other words, and this is actually why I want to present this slide, why you should depart from file formats and specialized solutions. The point I'm making here is that we're working on some amazing things that may sound to you irrelevant to genomics, and yet they're super relevant to the performance you're going to be seeing in several features down the road. For example, one of the things that we're working on is RLE compression for strings. So RLE compression specifically for sample names. This is going to give a huge compression ratio for the sample field that we have, but also it will allow us to compute directly on the compressed data. This is important because it's going to save a lot of computations internally. It is going to save a lot of memory budget. And when we perform distributed computations like the ones that Aaron showed you, it's not just the CPU that we're optimizing for. We're optimizing for memory as well, because the more memory, or the other way around, the less memory each of the tasks consumes, the more tasks we can spin up on a node. So this is very, very important. And this is coming up. Again, this is generic. It has nothing to do with TileDB VCF, but TileDB VCF builds upon TileDB embedded. This is going to be in TileDB embedded, and TileDB VCF will completely transparently inherit all of that. Another thing that we're doing is that we're very big in pushing down several computations from the tools we're integrating with. There is a question about Hail, and we're going to respond to that in a bit. But not only for Hail, but also for the SQL engines, for generic Spark that we're integrating with, and so many other geospatial tools. You can't imagine how common the operations are. You know, the filters, the aggregates, they're the same operations, whether it is VCF or LiDAR. So we are taking those computations, so we're going into the code of those tools that we're integrating with, and we're pushing this down to TileDB embedded to be computed closer to the data, so that we avoid copies. We do it in a multi-threaded manner, in a vectorized manner, and so on and so forth. Again, this will be inherited by the VCF offering. Another thing that we're doing on TileDB Cloud is fine-grained access policies. So far, Aaron showed you how to share, for example, arrays, but in their entirety, so an entire population genomics data set. Very soon, you're going to be able to share on the level of a variant as well, and actually of a variant field. So we're going that deep down and that fine-grained in terms of access policies. And finally, we're performing massive performance optimizations. Every day we have dedicated teams to work specifically on performance. So once again, all of this is going to be inherited by TileDB VCF. And this is the reason why I always suggest to all the domains, this goes way beyond the genomics domain, that you should not be focusing on specialized file formats. Focus on defining APIs, invite other companies and other engines to be built around those APIs, and then you should be able to move from one engine to another just by linking to a different library. You should not be focusing on file formats. You should not be focusing on specialized tools working on those formats. So with that, the presentation is complete.